Y'all hear me all right? Yes. All right. Thanks for having me. Happy to share about our experiences with our response to the SPaT challenge, kind of the things we ran into and what our plans are for the future in looking at this and where this is all taking us. Again, I'm Alan Davis with Georgia DOT, our Assistant State Traffic Engineer. So I want to kind of take back a few, a little tail back here, trip back to memory lane about how we kind of got on this path. And it started back around 2014 when we had internal discussions about whether we as an agency would pursue trying to be a pilot site when those solicitations were going around. And we realized at that time that we just had too many gaps in our infrastructure and architecture in terms of operations, that it wasn't a good time for us to pursue that. So we kind of tabled this effort and sat down about a year later and worked through some strategic planning, came up with some ideas about where we wanted to be, where we felt we needed to be as an agency within the connected and autonomous vehicle space, and put some things on paper and had some ideas. Shortly after about that time, the SPaT challenge came about, and since we'd already been thinking about this space and wanted to be in it, we quickly realized how important it was for us to be a participant in that, so we jumped on board as an agency and developed these kind of primary goals you see here about what we wanted to do with the SPaT challenge for us as an agency, not just in answering the challenge, but also where does this get us, what does this do for us, what does it take Georgia as a state in terms of transportation. So primary goal from that was to figure out how this connected space would need to work with us. How does it work for us? What network components, infrastructure pieces, and business process we had to do to support broad applications in the connected vehicle area. And on a secondary level, we wanted to deploy roadside units and equip vehicles with OBUs to be able to demonstrate and facilitate this technology. Really wanted to focus in kind of four major areas. Safety and mobility are the obvious touch points. Freight is a big thing in Georgia, so we always look for opportunities that we can improve and leverage our freight resources in Georgia. We have one of the busiest ports in the U.S. in Savannah, so it's obviously something that's always, as a DOT, it's always on the forefront of our mind. And we also wanted to pursue partnerships in this space to have a good idea of where we could work with others, work with the private sector, work with academia to touch all these spaces that we were trying to get into and leverage this technology to improve things that we were working on. So fast forward a little bit, one thing I would point out is in between that planning, the SPaT challenge and all this, that Georgia passed legislation to allow autonomous vehicles and truck platooning in Georgia, and then shortly after that we kicked off our pilot deployment as that was our official response to the SPaT challenge. So we identified 54 intersections on 2 corridors that we were going to target for SPaT and MAP messages. We did these strategically based on the types of corridors that these were, the kind of different topography they dealt with. One is a pretty urban, pedestrian focused, lots of traffic, all kinds of things going on kind of corridor, and another one goes through a very dense urban area with lots of tall buildings and bad GPS line of sight, and then another part of that same corridor is coming into town off the interstate, so it's a nice commuter stretch. So we had a lot of different characteristics that we could work with and play with and had good infrastructure in place to work with it. We also identified 12 ramp meters that we were going to place roadside units at, primarily for utilizing the amount of traffic that would be on the interstates that they were adjacent to for testing out basic safety message reception and broadcasting traveler information messages. That's a piece we have not completed yet, so I won't focus too much on that, but it's something on our radar. The ramp meters, of course, were selected because we had a solid network connection there and infrastructure to be able to easily deploy a roadside unit. We really targeted 4 applications that we look at that I'll talk a little bit more later on, but it was a red light warning, basically alerting you that you were not going to clear the intersection or were approaching a red light based on your trajectory. Pedestrian signalized crosswalk. Basically the idea here was to provide an alert to a vehicle that there was an activation of a pedestrian in an adjacent sidewalk. Nothing fancy beyond that, no automated detection or anything like that, but literally if there was a button pushed, that an alert would appear within the vehicle. Phase termination, next signal phase, kind of your basic SPaT message of this much time until the light turns green or red or yellow. And then your green band speed, which is an idea we played around with, that basically would display the minimum speed a vehicle would need to drive in order to clear the next intersection at green. That's what we targeted, and this is something that we started with a turnkey deployment with, we put out as advertisement. Atkins was the prime on that to help us deliver it, with Southwest Research as a technical resource on that program. And those 54 intersections turned on and went live in June 2018. Kind of a look at our approach of how we structure this within our system. So SPaT challenge, we're focusing in on the signal timing messages here. We have a ATC signal controller in the field that it was at the time, quote unquote, ready for connected vehicles. And of course, after a few software updates here and there and an additional application, we were able to get there. So the controller there is spitting out the NTCIP messages, and that CD app you see there is actually a software application that is residing on the controller itself, the driver signal controller. It's not a separate box or a piece of equipment that's needed, but it's like an app on your phone that is running. So I think it's kind of a unique and cool approach that we were able to leverage based on the infrastructure that we already had in place. So then that CD app then packages up the J2735 message out to the radio, which then passes it along to the vehicle over DSRC. One big component of what we were pursuing was to be able to have this open data approach as well. So we get calls, I'm sure a lot of other agencies do, from folks wanting to install some equipment on their network that sniffs out NTCIP messages or signal phase data to package up and broadcast out to repackage in algorithms that can sell back to various car manufacturers like Audi and BMW, so on and so forth. And we're happy to work with a lot of those folks as much as we can. We feel like we have infrastructure data that's important to get out to the public. We just have a lot of issues and concerns of plugging this device in, plugging this device in, plugging this device into our network, and how can we have any security or insurance of security with having those multiple devices plugged in on our network. So we decided the best approach for that was just take our data and provide it to the world through this open data approach. So we have a separate application that runs and connects back to each one of our signal controllers to aggregate that data and provide a data stream, and we're hoping to have it up and running and live here in the next month or so. One unique thing, too, about this approach that I think we have of having this application that resides in the controller is that, in theory, of course, this is a theoretical concept because it's, well, software manufacturers that are providing these things. So they say they can do a lot of things, and then it takes a little while to actually prove it. Forgive my cynicism there, but in theory, there's a lot of built-in integration and seamless application between the connected vehicle piece and the signal controller. So we have a working theory that we'll be able to do and handle things like signal priority through that application without having to introduce any additional equipment into the equation of this, that it's already something that there's a seamless integration between the DSRC, the CV app, and the ATC signal controller, that those functions can be exploited fairly seamlessly. But that's something that's on the whiteboard to figure out later on and test out. Just another look at our approach here visually. We envision, there will be intersections we have that have no DSRC radio roadside unit installed, and we do have some that are. And so we have a mixed medium of vehicles that are out there, as well as some that are not connected. Of course, they don't get any information from the infrastructure. And then you may have a cellular connected vehicle that you see there in the middle of the screen that is able to have, lots of vehicles these days have LTE connections built in, and that's one of the selling points of the Audi platform as well. We wanted to be able to utilize those resources, like I said, and so we aggregate that data and stream it out to the third-party service that's able to deliver it back. And of course, there's latency associated with that, but it's still a valuable asset. We feel like we're some of the infrastructure messaging that we can get out. And of course, the DSRC vehicle with the no latency approach is able to directly connect to the infrastructure. So a multifaceted approach that we hope will carry us a long way in terms of how technology evolves and what is down the road in the future. A quick look at the applications we are having. I mentioned the pedestrian and crosswalk one specifically. I will say that it's not one that we have working yet. It's a challenge we have and that, that's an undefined object in the DSRC connected vehicle world. Pedestrian push-button activation is something that does not exist on any kind of OBU as a standard. So we're kind of playing around with that and figuring out what we're going to do with it. Do we just write a custom script or something to simulate this as a proof of demonstration? Do we kind of leave it be? We see value in providing that information of pedestrian and crosswalk or any kind of pedestrian application to any kind of these connected vehicle applications. So it's something we want to keep on the radar and explore, but just something to highlight that it's not functional yet, and it's it's not something that's probably going to be demonstrated anytime soon. In Atlanta, on top of our 54 intersections, the city of Atlanta themselves deployed about 22 intersections of DSRC Radio 2 about the same time that we were. And separate deployment took a different approach in terms of how they integrated into their system and got it deployed in the field. And I'll talk a little bit about how that looked during our validation and testing. Having our system on one arterial and literally a block over, we had the city of Atlanta's deployment and what that looked like for us. But again, I want to reemphasize that our approach is, we have this valuable information. In this context, this is infrastructure information about the real-time signal phasing and timing information. And we strongly feel that having that data broadcast, there's folks out there that can aggregate that data and use it, and data analytics and improve efficiency, especially when we get back to the freight and logistics side of things. What that can mean, that's infrastructure information that those folks have not had before. And we strongly believe that that can really enhance their operations. So a quick look at what our deployment looked like. On the left there, you can see the radio up on a pole. We strapped it to an Astro bracket for easy maintenance. In the middle of the screen there, you see one of our OBUs that we use for testing, validation. And on the top right there, you see our original HMI. That's the Lear product that's out of the box, their HMI system. And on the bottom there, you see what the user interface for our, what resides on the controller, what that user interface looks like. One thing I want to point out, though, is as we were going through this, a lot of our applications we were developing were not compatible just yet for the Lear products, and the Lear HMI and the OBU were not on the most current standards and what we were looking at. So we figured out we needed to do something different. So we worked with our partners at Southwest Research to swap those things out for another product. Here you see a Coda wireless OBU in here. Now, I'm not endorsing one product over the other. It's just that that's what we had applications ready to go for in the amount of time we wanted to devote to this. So wrote all our applications on the Coda OBU, and there on the right you can see the application that Southwest Research put together for us as an HMI. That's a screenshot of the tablets we had on our card. That was what we used for our validation and verification the system was running to demonstrate the applications I mentioned before. GDOT certainly doesn't want to be in the app business. We don't want to charge 99 cents or anything to this and put it on the App Store or anything like that, but it was a useful tool in validation. One thing I want to mention here too about our application here that we were using is you see where I highlighted that generic RSU UDP. Southwest Research, as you know, is located in San Antonio, and our deployment is located in Atlanta, Georgia. So in order for the Southwest Research guys to be able to test and validate and work on these applications for us, it didn't make a lot of sense for them to have to travel to Atlanta every time they needed to get data from the field about how these things were operating and what they were broadcasting. So we were able to leverage our applications to create this data stream that could be received directly to Southwest Research in San Antonio, and they could replicate it in the field and test and validate what they were seeing and doing all the way out in San Antonio from here in Atlanta. I just think that's an incredible application of the technology to be able to utilize this on the internet side of things. So just want to highlight how I thought that was interesting. Here's a look at what our application interface looked like here and point out a couple things. You see on the left your phase service time remaining in the signal head. That particular approach you see right there had multiple moves associated with it, the permissive left turn as well as the through forward. You see the intersection name that showed up. That's populated from a local table on the tablet in the app, but based on what the intersection ID is. This minimum speed required to clear green. So you see it's highlighted there, a target speed of 10 miles per hour. that is calculating that target speed based on the green band that the controller is spitting out through the DSRC and the minimum time the termination. And based on your trajectory, it's calculating on the OBU what speed you need to go to be able to hit that intersection, cross that stop bar before it turns red. So a really cool application, I think, as a guy with a lot of signal history and background. I thought that was pretty fascinating. And of course, your vehicle speed is highlighted there, and all the way on the right there in that tiny text is all the debug information that we used to be able to see what the current state of everything was and how that looked. Another shot here of what the red light warning. This is another application too, where it calculates from the trajectory that you're going to hit a red light. It would pop up that big red ball and alert you to it. Validation and testing. This is an important part of our deployment that we worked with Southwest Research to do. We wanted to ensure that what we were broadcasting and the information we had present was in fact true and accurate and what it was meant to be. And here's just a list of all the things that Southwest Research was looking for when they did this. And a lot of this was done through this remote validation, as well as recording data as they were driving through that they were receiving from the RSUs. All the way from the properly formatted J2735 compliant messages. That's an important one too, because I mentioned the adjacent corridor through another deployment that was next to ours. While we were out there doing this, the Southwest Research guys would drive that corridor and record it and do some validation as there. And even two adjacent deployments deployed at about the same time, you could see that, of course, ours was the correct and proper one, according to the guys doing the validation and testing that we were paying. But next door you had a message set that was not properly formatted compliant messages. So it's just fascinating that two corridors deployed about the same time, adjacent to one another, were having different information being broadcast. So just to emphasize that validation and testing, to get that ground truth that this is good information is incredibly important with all these deployments. There are a lot of off-the-shelf products out there that say they can do X, Y, and Z with connected vehicles, and it's really important for agencies out there to ensure that the data, the messaging that's being broadcast there is actually true, accurate, up to code, up to standard for what it's supposed to be. Some challenges we had with our project, device interoperability. I know I've heard Blaine Leonard speak of this quite a bit. I mentioned that we had to switch between the Lear OBU and the CODA OBU because applications are written a certain way for a certain code on the CODA wireless OBU, and it didn't translate directly to the Lear OBU, and we have to go through this effort to be able to port that from one OBU to another. Does that controller talk directly to the RSU, or do headers have to be reformatted? Is it in binary, or is it in ASCII, ASCII, or all these things were well beyond my understanding and comprehension of coding and knowledge. I just know that it takes a lot of work to get A to work with B, to work with C, to work with A. That interoperability is a big challenge. It's still a big challenge, and I hope that as these deployments proliferate, that's something that gets worked through and sorted out. Map message creation and validation, that was probably, as we'll see in a minute, where we spend a lot of our time is not only map messaging, but that validation and troubleshooting of all this data is crucial. Most of our expense, most of our effort has been on creation and validation of map messaging and GPS correction efforts. Protected permissive left turns, we had an issue with that within our particular application on our software controllers. It's currently set up to where it only recognizes the arrow. So when you introduce this permissive element to a left turn, it's looking for a red arrow, which means a yellow arrow or a green arrow, which are all protected movements. But as soon as you introduce this permissive movement, it doesn't really know what to do because it's seeing both a red arrow and a flashing yellow arrow. So some software confusion there that we have to get worked out, but initially that was a problem and something we've isolated and been able to work out. I mentioned ramp meters, how we are deploying there, but there's not really any defined objects for ramp meters at this time. I mean, I guess there's a green ball and a red ball, but what does that mean and what is it going to look like when you deploy it within a connected vehicle system like this for SPaT messaging? Blaine mentioned security credentialing earlier. We early on discussed SEMS of whether or not we were going to attempt it with this, and we realized that it was a bit too much for us to chew on for our initial 54 intersection deployment, especially when we had complete control over the broadcast and the reception of the data that was going to be used here. So it's not something we initially pursued, but we put an asterisk next to it in our ConOps as something we definitely needed to figure out as soon as we started to explore these partnerships. And again, a limited fleet that we ran into. We only have 50 OBUs as part of this pilot that we outfitted. So, and we're in the process of outfitting those. And so that's not a lot of users of the system, but it's something that we hope that will continue to grow. So I want to talk just very briefly on my final few minutes here about where we're going from here. We very early on hoped that this project would be successful and that it would be something that we could make scalable to the rest of the state. So for this type of application, we needed to have, we really felt like we needed to have 3 components at an intersection to make this work. You need to have communications at the intersection for remote management. We needed to have, okay, we've got that in most places. 90% of, or 100% of what GDOT operates and maintains has communications to it. We need to have an ATC signal controller that could handle the SPaT messaging. We have a scalable infrastructure for that. We have these ATC signal controllers all over the state at most locations. Okay, check. So the only piece we're missing here is this DSRC radio. And so combine those 3 things and we see that broad deployment potential in Georgia, that this is something that could quickly scale out to a lot of different places. And so over the next few years, we have targeted to deploy at over 1,700 intersections in Metro Atlanta. This fits right into a regional traffic operations program that we have here in Metro Atlanta that is active management of arterials. And so we already have a lot of effort and infrastructure invested into these locations. So adding on this DSRC and the work that goes with it to us is similar to deploying another ITS device with a little bit extra. So we're going to scale up what we have done already on our SPaT challenge corridors to the rest of the city. And the idea we really approach here is that, okay, we can deploy this at 54 intersections. And if we go to somebody and say, you know, your average citizen say, hey, this technology is present on these 2 roads in Metro Atlanta. What do you think about that? It's like, oh, well, that's interesting. It's cool to see it. But then when you approach the subject and say, well, what if you had this technology, this information, this connectivity on every major highway in the Metro Atlanta area? And that's where we feel like we really start to see those light bulbs go off in terms of application potential and use of this technology. And you know, we certainly want to see it proliferate as an agency for the benefit that we'll get out of it and the benefit we see that the traveling public will get out of it. So we're going to put our foot forward and aggressively, Blaine mentioned progressively earlier, that our deployment plans were, I think it's aggressive is the proper adjective here. We'll see if we can pull it off. But already in the works, we have the first 250 of that 1,700 that we plan to have installed by the end of 2018. Just to look here, the blue lines there represent where those corridors will be. And again, our objective here is connectivity on every major arterial in Metro Atlanta and have that open data stream at all these locations as well. So hopefully by the end of the year, that's where it will be. I will mention that a big challenge for us is getting the physical RSUs delivered and to us to be installed. That's been our biggest challenge, is finding the supply for the equipment so far. So fingers crossed on that moving forward. We hope to have it completed again by the end of June 2020. One final thing about that of what that deployment itself will cost. We broke it out into 2 years, kind of identifying, you know, the front load of it will be a little bit lighter to kind of get things moving and hopefully get the equipment inventory. And then the second year of it, they're being more aggressive with almost double the amount of deployments we will have out. So hopefully it will be a well-oiled machine by that point. But $7 million based on our contract prices that we have. I want to mention there, you know, the RSU and deployment is about $2,100, and the other half of everything that we're running into is the configuration and support of the roadside unit. So again, that map message creation, troubleshooting, and all that fun stuff is a big part of what it takes to get these things operational and working. So Here's what it costs to do 1,700 intersections in Georgia with an RSU, about $7 million. Again, I'll leave it at that. If you have any questions, there is my information, and I want to hand things over now to North Carolina DOT for their